All right, ladies and gentlemen, we are in chapter 12, which is pretty much our 5th unit of Algebra 2. So when we start talking about this, we are talking about the probability. We're talking about measuring the odds of something that's going to happen. And before we do that, we talk about what's called the fundamental counting principle. So the fundamental counting principle is kind of a way to think about it is to figure out how many different license plates could be formed using all the possible letters and all the possible numbers that exist. Okay, so if we look at Minnesota, it goes letters, then numbers. All right, so if you want to think about this, here's kind of what you're thinking about. So you're looking at letter, 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 number, number, number. Well, how many different letters are there? 26. And you can repeat a letter over and over and over again. So I could have 3 of the same letter. I could have A, I could have X, I could have whatever. So then the numbers are going to be 10, 10, and 10. Why? Because I could have the same number 3 times. I could have 111, I could have 777, I could have whatever. The fundamental counting principle says that to figure out how many different possible ways there are to do that, you are going to multiply all 3 of those, or all those numbers together. That will give you the total number of possibilities of license plates. So now that's 1757600. So that's about 17.5 million, 17.5 million possibilities. All right, so a couple things to be familiar with, the general terminology. When you're talking about an outcome, that is kind of what happens. That is the result of a single trial. So if I'm flipping a coin, it's either going to be heads or it's going to be tails. So that would be my outcome. If I'm rolling a dice, it could be 1 through 6. All right. Sample space is everything that could happen. All right. So if I roll a dice, my sample space is going to be 1 through 6. If I roll 2 dice, my sample space is going to be 2 through 36. So those are all the possible outcomes. Oops, wrong button. So that is your sample space. Event is something that happens. So it consists of 1 or more outcomes of a trial. So it's kind of rolling a die, flipping a coin. That is the event. Independent events have no outcome, have no effect on the other. So the choices of letters and digits to be put on a license plate, it doesn't matter what the first letter is. It has no bearing on the second letter. Dependent events is going to be when one outcome affects another. Okay, kind of a good word to look for is going to be with replacement and without replacement. Those are kind of your key words. Okay, so if you think about independent events, well, flipping a coin, each individual flip would be an independent event. Why? Because a coin has no memory. A coin does not remember if it's landed 5 times in a row on heads. It doesn't matter. There's no change in the probability for the next flip of the coin. So independent events. One way to do it would be to make a tree diagram. And the second method would be the fundamental counting principle. The tree diagram gets really long and really drawn out, and you're not going to like it after about 3 things. So let's take a look at the problem. Sandwich cart offers customers a choice of hamburger, chicken, or fish in either plain or sesame seed bun. How many different combinations of meat and a bun are there? So you've got a hamburger, you got chicken, you got fish, and off each one you can make either plain or a sesame seed. So my total possibilities is 6. Now the fundamental, you can do that, and it's really easy when it's 3 things followed by 2 things. Okay, when it's something really, really elaborate, or when you go back to the license plate example, it's something really drawn out, then it gets a little tougher. So fundamental counting principle. How many meats are there? 3. How many different kinds of buns are there? 2. Multiply those, 6. So here's kind of what the fundamental counting principle is. So If one event can occur in m ways and another in n ways, then the number of ways both events can occur is m by n. This can be extended to 3 or more events as well. For example, if 4 events can occur in m, n, l, and k ways, then the number of ways all 4 can occur is m times n times l times k. All right, that is really weird. Let me put that into a context. So let's say that you're trying to pick out an outfit in the morning, and let's say that you got 12 shirts and you got 7 pairs of pants. All right, according to the fundamental counting principle, you've got a grand total of 12 times 7, or 84 different possibilities. All right, but I can also include, what if I've got 6 pairs of socks and I've got 3 pairs of shoes? So once I do that, then I'm going to take 12 times 7 times 6 times 3, and that's going to be the total number of different outfits that you can have. Now, of course, this isn't taking into context, well, this doesn't go with this, and this doesn't go with this, or whatever. But just flat out, you've got over 1,500 different outfits you could do. So, to check a voicemail, owners may have to enter a 3-digit code, determine whether choosing each number is an independent or dependent event, then determine how many codes are possible. So the question I'm always asking myself is, can I repeat a number? Because if I can repeat a number, it's independent. There's nothing in here to say, well, you can only enter 1 digit once. No, absolutely not. 3-digit code, boom, boom, boom. I could have 111. I could have 777. I could have whatever I want over and over and over again. So I'm voting for independent. So it's going to be 10 times 10 times 10. Why is it 10? Because you have digits 0 through 9. So 10 times 10 times 10, you got about 1,000 possibilities for that one. So Carly wants to take 6 different classes next year, assuming each class is offered each period. How many different schedules could she have? Well, this one I think is going to be dependent. All right, this one's going to be dependent, and I'll explain kind of why. 6 different classes. If she takes 1, does she have to take that 1 anymore? And the answer is no. So, I mean, if you're trying to think about, well, I got to take math, and I got to take Spanish, and I got to take English, and I got to take a whole bunch of other ones. Well, if I take Spanish first hour, am I going to sign up for Spanish again later, 5th hour? No. Once I sign up for Spanish, I'm done. So I got to think about how many different possibilities I could have. So you got 6 hours. So that first hour, I've got 6 choices because these are my 6 classes. All right, but once I sign up for one, I don't have 6 classes anymore. I've only got 5. So once I sign up for that one, there's 4 classes left for 4 spots. So that means I've got 4 here, 3 here, 2 here, 1 here. By the way, when this occurs, when you've got 6 down to 1 and you're multiplying them all, that's called a factorial. And here's what it looks like mathematically. It's called a factorial, and all it means is it's marked with an exclamation point. All it means is multiply from that number times every integer down to 1. Don't multiply by 0, because once you multiply it by 0, your answer becomes 0. So once you do that, you get 720 different possible combinations. So a garage door opener has 10-digit keypad, and the code to open the door is a 4-digit code. How many codes are possible? So can I enter the same number 4 times? Yes. How do I know? Because I know people that have actually done this. But you still have 10 choices for each one. So how many different possible combinations are there? 10,000. Each player in a board game uses one of 6 different pieces. 4 players play the game. How many different ways could the players choose their game pieces? All right, so we got Monopoly. Wow, we got the old school Monopoly pieces. All right, so here's kind of where it's going to be dependent. It's going to be dependent because once somebody takes a piece, nobody else can take that piece, all right? So I always like to be the battleship. I don't know, I always thought in my mind as a kid that I could just like launch things off my battleship and destroy other people's houses. which I always thought was kind of cool, but everybody I played with really hated it. So I always like to be the battleship. But if I pick the battleship, nobody else can be the battleship. All right? If, my brother always liked to pick the dog. Nobody knows why. But once he picked the dog, nobody else could pick the dog. So that's why it's going to be dependent. All right? So if I've got 4 players playing a game, that first person, whoever he is, gets the first pick. He gets all 6 to choose from. Once he picks one of them, it goes away. All right? So let's say I got to go first. I took the battleship. That means there's 5 pieces left for the second person. There's 4 pieces left for the third person. And there's 3 pieces left for the last person. So it's going to be dependent, if nothing, no other reason than because once I take away one of the options, it's no longer an option. All right, so once I do that, there's going to be 360 different possible ways to do that. All right, that's all I got. Take some time, make sure you got these correct because they are very detailed and they're easy to get confusing.